Good morning, good afternoon, or good evening from wherever you're watching this webcast. Today we'll be covering leveraging Microsoft Azure for your DevTest workloads to increase your business agility and ROI while lowering your total cost of ownership. Here's our agenda, a little bit about Statera and myself. We'll cover the Azure platform from a high-level perspective, as well as dive deep into some of the specific feature sets of the platform. We'll talk about enabling innovation with Dev and Test workloads in Azure, as well as leveraging Azure for SharePoint and SQL Server, both in a Dev Test scenario as well as a production environment, where both those workloads and features are part of the solution. And as many of you are aware, DevOps and management in Azure is a important and hot topic in today's IT and cloud management space, and so we'll go into how to do that to ensure that your DevOps and cloud assets are aligned with your current implementation in terms of your processes. A little about Statera and our Azure experience. My name is Earl Agestad. I am the GM for Custom Solutions at Statera, as well as our Azure practice lead. I'm also a Microsoft VTSP for Azure. My email address and Twitter handle is there if you wish to contact me. Statera has been an Azure Circle program member and charter member since 2010, really since the inception of Microsoft's Azure initiative. We're also a Cloud Accelerate partner for both Office 365 as well as Azure, and have implemented numerous Azure and Office 365 solutions for our customers. We leverage the Azure cloud and its various assets and have expertise across all of our three business units. Myself, I lead the Custom Solutions team, which focuses on platform as a service and infrastructure as a service solutions on Azure, as well as DevOps and application lifecycle management, which is a very critical component of ensuring that your cloud migration as well as your operations processes align to leverage the cloud's massive scale and still reduce your internal operational costs. Single sign-on is obviously a very important topic as you extend your internal assets to the cloud. We also do integration with Azure Service Bus, and my team also has a direct responsibility for building mobile solutions that are cross-platform, used across iOS, Android, and Windows 8 via Azure Mobile Services. My counterparts in the Portals and Infrastructure team focus on SharePoint, all up, including SharePoint in Azure, leveraging the Infrastructure as a Service or IaaS offering. We have an Office 365 practice, and we obviously focus on identity management and single sign-on there. And then leverage our public and private cloud expertise, particularly in terms of Hyper-V, to build those solutions. And then a critical component that we will talk about later is leveraging System Center as your one pane of glass to manage your on-premise implementations of a private cloud, as well as also leveraging System Center to monitor and control your Azure assets through one pane of glass. Our information management team focuses on SQL Server workloads, both platform as a service and infrastructure as a service. We have a real rich BI team focusing on dashboards, reporting, and that workload, as well as data warehousing, and we also focus on big data via the Hadoop offering in Azure. So let's take a few minutes and talk about Azure and how it fits into the cloud taxonomy that you may be familiar with. In the cloud, as opposed to your traditional workload where you manage every asset of your infrastructure, both from the networking, virtualization, hardware, operating system, and your applications. When you start moving to the cloud, there are three scenarios that you will hear. One of them is IaaS, or infrastructure as a service. As you can see on the diagram, in an infrastructure as a service implementation in the cloud, the vendor, in our case Microsoft, manages the networking through the operating system tiers of the server, and you have the capability to manage the middleware, runtime, data, and applications. In that sense, you are basically leveraging Microsoft's expertise to provision and scale servers, which you have automatic and direct control to to install whatever software you wish to run on that server. In a platform as a service or PaaS implementation, in addition to the OS, Microsoft basically also controls the middleware and the runtime, and you deploy your data and applications onto those servers. In a software as a service implementation, and those software as a service implementations that you may be familiar with are assets such as CRM Online. We have a partnership with Twilio for SMS. Salesforce is another large software as a service implementation that you may be familiar with. In this scenario, you are basically paying on a per user or per subscription basis to a service, and the entire stack is managed by a vendor. Our most common implementation these days in this scenario is Office 365, where Microsoft manages the entire Office 365 infrastructure, and you simply provision and add users through the O365 portal to provide Office 365 capability to your end users. Azure now spans all three of these tiers. It started as a PaaS solution in 2010. IaaS has been in place for approximately a year and a half, actually longer in preview, but in production for well over a year and a half. It also has a software as a service arm in it where you can add third-party SaaS solutions into your Azure implementation as needed. Our most common use of the SaaS model is typically in the area of SendGrid for email, as well as third-party solutions for items such as D&B, address verification, and the software as a service infrastructure and feature set is growing rapidly as you listen to this webcast. All of these assets can be explored through the Azure portal. One note of consideration is that the Microsoft Azure platform is the only cloud platform that is in the Gartner Magic Quadrant for both IaaS and PaaS implementations. In terms of Windows Azure scale, there are currently 16 data centers across the world, 4 in the United States, 2 in EMEA, 2 in China. Azure is the only cloud provider with a direct implementation and infrastructure in China. There are 2 in Southeast Asia in addition. Australia is coming online shortly. It is in a preview mode right now. Brazil was just launched earlier this month in June. So 16 data centers currently, and that will grow. In terms of security and compliance, this is a very secure and compliant infrastructure. It has both ISO 27001, SOC 1 and 2, certifications from the Cloud Security Alliance, from the federal government and government agencies via the FedRAMP certification. PCI and DSS level 1 has been recently added in terms of those who are dealing with e-commerce or credit card transactions. HIPAA and FERPA is also now fully certified in the Azure cloud. There is currently a 24-node global CDN for content distribution network across the world, very rich in terms of those of you who may be looking at some sort of a image or media streaming or video sort of workload, and you wish to deploy those assets to the nearest edge server, depending on where your users are consuming your assets. Global support is interesting in that your support and how you basically get support from Microsoft for the Azure platform is exactly how you get it today. The global support is across the world in your local account team or your market as you currently get support from Microsoft. Those local account teams, as I mentioned, are across the world, and interestingly, you can set up your Azure consumption and your Azure subscription model in multiple currencies. So we have customers who wish to transact portions of their Azure subscription in US dollars, but they also have assets in other portions of the world where they wish to transact in the local currency based on how they basically charge back for consumption based on their internal accounting practices. From a platform-specific all-up discussion, Azure focuses on 3 tiers. There's an app services tier, which has a rich offering around platform as a service. There is caching built in through both a Redis option as well as a distributed cache stored in the cloud. A single sign-on and identity management is very rich. As I mentioned earlier, the service bus is the key for integrating your on-premise systems to the cloud programmatically, should you not wish to do that through a networking option that we'll talk about in detail a little bit later. SQL database is in 2 flavors. There is SQL Server in an IaaS, or infrastructure as a service implementation, where you are in control of the SQL Server, large scale up to 24 cores at the current time, as well as support for HD Insight, and then a very rich storage architecture around table or NoSQL sort of implementation, as well as blob storage for large scale storage of assets such as images, media, and the like. Infrastructure services support a full and rich virtual machines implementation, as well as a virtual network and VPN infrastructure for connecting your on-premise network to the Azure cloud through a secure IPsec, or a larger express route implementation that we'll go into more detail later. There is a global traffic manager offering that allows you to basically provision your servers in multiple locations in the world and have Azure properly route the traffic to the correct nearest asset depending on the end user's IP address or origin. And as I mentioned, there's a very rich content delivery network. Now, most users, when they're building apps in a platform as a service, leverage assets of the app services tier to build those apps. But if you're doing infrastructure as a service where you wish to control the implementation of your solution through virtual machines, you can connect those machines to your VPN and provision virtual machines in the Azure cloud. To give you an idea of the scale, these were the current metrics that Microsoft reported at the Build conference in San Francisco in early April. As you can see, the scale of the Azure platform is tremendous. A couple of items to highlight here is that there are over 1 million databases as of April 2014 currently running in SQL Azure. There are over 20 trillion storage objects in the Azure storage subsystem. The authentication workload is tremendous, as you see. There are over 13 billion authentication requests currently per week. So any authentication or single sign-on implementation where you leverage live IDs or Active Directory or Office 365 authentication is run through the Azure Authentication Service and has tremendous scale. The current requests per second is well over 2 million. And as well as there are over 1 million developers registered with Visual Studio Online, which is the software as a service if you'd like implementation of Microsoft's TFS ALM product, but actually running in Azure, which allows you to provision and use most of the assets that are in TFS in an on-premise implementation through a portal that is available to you and to your teams across the world through the offering known as Visual Studio Online. I wanted to take a few minutes and spend some time on the announcements that were at the Build conference in May around enhancements to the Azure platform. Of interest here are the ones in bold. Autoscale is the offering provided in Azure that allows you to scale up and scale down on demand depending on your performance characteristics of your specific workload. So most customers have a typical pattern around peak scale limits, where perhaps you have a environment where you need to scale up during the day and then at night scale down, or you need to burst around Christmas holiday shopping or certain calendar events such as Valentine's Day or something similar to that. We work with customers to scale up and scale down based on their performance characteristics of their workloads. That is built into the product. In addition, there was integrated remote debugging supported in Visual Studio. This allows you to basically attach to your virtual machine and debug a solution that may be running in the Azure IaaS implementation and debug that locally through Visual Studio. So those of us who have had to do remote debugging before, the configuration to remotely debug a solution remotely from your local Visual Studio was cumbersome in the past. This has been seamlessly made very easy through this integrated remote debugging. We'll talk about details on VPN networking a little bit later. Static internal IPs have been allowed to be provisioned now. Previously, you were not allowed to provision IP addresses and have those statically ensured to be assigned to you should the machines in your IaaS implementation shut down. That is now allowed. As I mentioned, the traffic manager has also been put into GA as of May. One item that's of interest here is that if you are doing a PaaS implementation of a website, you now get 1 free SSL certificate and 5 SNI certificates at no cost as part of either a shared or reserved version of the website. One thing to mention is that the Azure platform has embraced open source and non-Microsoft operating systems and implementation. So there is full Java support, and you can run Java in the Azure platform. On the data side, SQL databases in Azure, the database size has been increased to 500 gigabytes per database. The offering around self-service recovery has now been built in, which allows you to have Azure provide backups and self-service recovery as part of that offering, so you no longer have to work about automatically backing up your SQL Azure databases on your own through a number of means. Geo-replication has also built into SQL databases. One item to mention is that Oracle is certified, and the Oracle database offerings are certified to run in Azure. That has been out for approximately 6 months. So if you do have Oracle as your database tier on the back end, you can run that in a virtualized environment in Azure via IaaS. Storage continues to decrease in price. Price drops up to 65% were announced at the Build conference. One item to note is that if you go out and search on Forrester and Nasuni, you will get storage benchmarks relative between Azure, Amazon, Google, HP, and Rackspace, where you can see that the Azure storage subsystem has now the best benchmarks in terms of storage. And from an HT Insight perspective, there is also now Hadoop 2.2 support, and .NET 4.5 support is now also supported in HT Insight. Further announcements occurred in TechEd earlier this month. We'll talk about most of the networking features later, but suffice it to say, a couple of items of interest here is that you can now do internal load balancing within your IaaS architecture. Previously, you had to use the Azure load balancer to do load balancing. You can now internally load balancing your implementations through your own IP addressing scheme. Large instances in A9 and A8 instances were also added to the compute tier for large-scale implementations of Azure. In addition, Azure Files is a new offering that is in preview at the moment, which allows you basically to create an SMB 2.1 aware file share that can be leveraged by your other Azure PaaS and IaaS instances as basically a network aware file share. Azure Remote App allows you to have your users get access to your applications in a controlled manner through RDP technologies, where they RDP into servers where you control the apps that they have access to, and they access those apps that are housed on a number or however many IaaS implementations of VMs that you put those applications on. So let's talk a little bit about enabling innovation with Dev and Test in Azure. When you think about moving to the cloud innovation paradigm presents challenges for IT. Particularly, how do I integrate my existing investments that I have? Most of us have your existing servers and IT infrastructure either on-premise or in your own data centers or perhaps in third-party co-location facilities. You also have IT staff that manage those assets. So as you think about using the public cloud, you're not thinking of it in a silo. Ideally, where possible, you'd want to integrate the public cloud with an existing IT, manage it node differently, and even have applications with parts running on and off premises. To give you an idea of where most companies are at in terms of their adoption in the cloud, the latest IDC findings show 80% of enterprises already adopting hybrid cloud, and 85% of new companies or startups are using some aspect of cloud computing to deliver quick solutions to the market and or their business. You're also probably running a variety of OSs, databases, and middleware and tooling such as CRM from multiple IT vendors. Your developers are proficient in multiple languages and your apps are written in multiple languages and frameworks. In other words, your IT environment is complex and heterogeneous, and you want to make sure the cloud platform you choose is able to handle your heterogeneous workloads. Next, and perhaps most importantly, you need to abide by a number of security and compliance initiatives. The rest of the business trusts your IT organization to run apps in a secure and reliable manner. So you want to make sure the public cloud platform and the vendor who provides that service is using it and is trustworthy, and it, for example, has the right experience and expertise and has the necessary SLA and security controls in place. Now, Azure, as I mentioned earlier, has embraced open source and cross-platform. From an operating system perspective, you can both run Windows images as well as Linux images. The database tier supports both SQL Server, MySQL, Oracle, and Hadoop. One of the workloads that we see a lot of customers using Azure for is for mobile devices. Azure Mobile Services provides a rich ecosystem for you to target Android and iOS products and the languages themselves, not only along with Windows devices. So you have one single cloud service that can support all those platforms. CMS platforms are built in terms of WordPress, Joomla, and Drupal, as well as other products such as Umbraco. And as I mentioned earlier, this is not only a Microsoft .NET platform. There is full support and rich ecosystem for Java, Python, PHP, and in particular Node.js's importance is growing, and that is fully supported in the Azure platform. So when you think about using the cloud for dev test workloads, what you have is you have to balance the application owner and the IT owner in that sort of workload. The application owner has challenges and needs typically associated with rapidly requiring your IT organization to provision environments for test and development or for experimentation with new initiatives they may have. And they also typically want to use a number of servers for scalability and load testing. Now, the data center team and your IT infrastructure team, while they are trying feverishly to keep track with or keep up with your application and business users, they are under an edict to maintain your production SLA as well as determine how much server capacity they can support these budgets required for ongoing initiatives. And as well as there are licensing constraints built into that require them to determine what they can support given their budget constraints and forecasting. And then obviously as you spin up and provision servers for your application owners, they have to have proper infrastructure in place to support resource contention that may occur with increasing virtual machine utilization. So if you think about leveraging Azure for dev and test, what does that look like? Well, what you do, or what Azure provides your application owner, is to self-provision VMs and scale as needed. They can use the existing tools and languages they have, and they can provision virtual machines from pre-configured images, as well as leverage tools and services to perform load and scale testing. And what's important is that, as you may be aware, the cloud taxonomy is a pay-as-you-go model. So you only pay for resources that you are using, particularly in terms of compute. And when you are done with a specific workload or use case, when you shut down an Azure VM, you no longer are charged. It's a pay-as-you-go model, which is charged to you per the minute of compute time used. What this allows you to do from a data center and IT perspective is to control how those images are provisioned. Think about how you can manage those images in a regimented sort of self-service IT model, where you control the visibility and governance of who can provision these images and set up the connectivity and to your data center and cloud based on policies and automation that we'll talk about a little bit later. And you get optimized price performance because you can manage when those instances are running and when they are destroyed or torn down. One item we'll go into greater detail on a little bit later is the use of System Center as your orchestration engine and management platform for not only your on-premise virtual environment, but also for Azure. So how does Azure support your application owner's needs? Well, what the tools that you use to do that from an automation perspective is, from a hybrid networking capability, you create VPNs, or virtual private networks, that allow you to extend your on-premise data center to the cloud. PowerShell is the foundation for automating Azure. The entire Azure API is exposed through a set of REST interfaces that can be accessed through .NET Service Management API, but also through Azure PowerShell, and we'll go into detail on that a little bit later. What this allows you to do is to actually create sandbox environments for dev or DevTest or QA, and allows your end users to experiment and innovate by using either images that are out of the box provided to you through Azure's portal, but you can also create your own custom images or create ones of your own based on provisioning what we call a golden version of an image, saving that image into your own Azure gallery, and then provisioning existing or new versions of that workload based on that image. You can also use this sort of paradigm to do third-party solution validation, where perhaps you need to do test Windows updates or hot fixes to certain portions of an application that you need to test in a controlled environment, where you do not want to install it within your own infrastructure to ensure that no changes are made without proper validation. So one of the items that we wanted to talk about is testing and scale workloads. The cloud is a perfect candidate to use for that. The tear up and tear down paradigm is where you basically create a baseline image and containing data, and as you go through a testing cycle, you provision those servers with the necessary initial set of data. When you're done with your use case of data validation, you tear down those images, and then when you need to build up the same version of the baseline environment, you basically provision the servers back up from the baseline image. This provides you immediate access to a baseline image that can be used over and over again and can be provisioned seamlessly and rapidly. What this methodology also allows you to do is do unit and regression testing, where you can actually do scale up and run in parallel unit and regression test plans when needed, and when done, tear those down. Load and performance testing is ideal for the cloud because you can spin up as many instances as you need to determine where your system and your application breaks. Whether it's the web front end tier, the middle tier, your database tier, you can spin up as many instances as you need to determine where your application breaks and how you basically need to auto-scale your application based on response. Customers we see are also doing scenario testing where they do specific customer rollouts of their solution, and they want to see what the impact of changing their core solution for a specific customer may occur to their system. And security and compliance testing is an ideal workload in the cloud because if you have a sandbox environment for vulnerability and penetration testing, you can actually do that seamlessly in Azure. Do that without actually exposing your internal network to those sorts of penetration tools. I wanted to spend a few minutes talking about Azure Storage, which is the bedrock foundation for Azure. Azure Storage allows you to create up to 500 terabytes per storage account. Remember, you only pay for the storage you use. So if you provision Azure Storage of 100 gigabytes, and that is what is used in that storage account, you only pay for the amount of the storage you are using. The storage can increase automatically for you. It scales seamlessly up to 500 terabytes, as I mentioned. The storage architecture is accessible both from Microsoft Azure applications as well as securely via an API that you can call into using X.509 certificates. And as I mentioned earlier, you can also do work with the storage architecture and the rest of Azure, frankly, through Service Management API and PowerShell. The storage types typically are of three types. The tables is the NoSQL sort of implementation where you control the schema of what data that's stored in the tables. Blobs are associated with storing artifacts such as images, media files, documents, etc. There is queuing built in as well in the storage architecture for a sort of MSMQ or FIFO implementation of queues. Important to note is that when you provision a storage account in an Azure data center, you get 3 copies of all data that's stored in that storage account within that data center. So you have DR built into the storage subsystem automatically. As I mentioned earlier, costs are always going down. Right now, the current cost per month per gigabyte is as low as 0.024 cents per gigabyte per month. The more you consume, the lower the price goes, even lower than what is noted here. So let's talk a little bit about Azure Virtual Machines and go into a demo of the Azure portal. So to getting started with Azure Virtual Machines is very simple. There are 3 options for you. You can go through the management portal that we will do now. You can also use scripting through Windows, Linux, and Mac using PowerShell. And as I mentioned earlier, you have a full rich REST API that allows you to basically programmatically provision VMs through code. Images are supported both on Windows as well as Windows 8 now. Recently, Windows 8 client instances are available for test in Azure, as well as having CentOS and OpenSUSE support, as well as Ubuntu is support as well. And we'll show you the Azure portal in a while. Azure VMs are created as VHDs, exactly the same as the technology used where you create an image using Hyper-V. What's important to note is that when you do that, that VHD is transportable between Azure's cloud infrastructure back to on-prem, meaning, and it's both ways. What that means is you can take a VHD that you have running in Hyper-V currently and copy that up to Azure as an image and spin it up. It'll be fully binary compatible. There will be some networking changes, obviously, depending on how that image is set up. But if the image is sysprepped, you can transport it from your on-premise Hyper-V implementation to the Azure cloud and vice versa. So you can take a fully implemented Azure set of virtual machines and move those back down to your on-premise network. And then the VMs are created, as I mentioned, in the blob storage. So let's look at a demo of a virtual machine provisioning. What you see in front of you is the Azure portal. I have logged in using my Windows Live credentials, and I want to create a virtual machine. So I go to virtual machines, and you see the list of my virtual machines running currently. If I want to create a new virtual machine, let's look at the gallery. You look in the gallery, it's a very rich set of servers, and I wanted to highlight MSDN. And we'll talk about your MSDN benefits that are provided with you in Azure. MSDN is supported, and when you have an MSDN subscription tied to your Azure subscription, note that you get access to baseline images where you need to do development associated with a BizTalk, Windows Premium update, Windows Visual Studio Ultimate. Now, if you notice this image here, this is a very rich set of capabilities. If you look at Windows Update 2, you'll notice that this version comes with a trial of SharePoint. It comes with SQL Server 2012, as well as the entire Visual Studio Ultimate Update 2 image. A lot of our customers are leveraging Azure's VM capabilities to provision new instances for their development teams and then shut those down at night for those who may be working part-time or need a uniform image to work with. So let's go and provision a server. Let's choose Windows Server 2012. When you create that, let's call it Azure VM. We'll talk about basic and standard tiers a little bit later. Basic and standard tiers allow you to provision VMs at even a more reduced price than the standard pricing if you do not need load balancing or SLA requirements. So for DevTest, this is ideal because, as you can see, you can go down to a 1-core 1.75 gigabyte machine. If you go to standard, you get the same machines. You pay more because the assumption is you're putting this into some sort of an HA load balancing high availability solution. But let's just choose basic, and you choose the instance you want. Let's choose the username and password. Let's do admin 123. Set in a default password. Now when you go here, what you'll notice is that there is an item called a cloud service. A cloud service, as noted here, is a container containing one or more machines. So if you're setting up an infrastructure that may have web front-end servers and SQL servers, you want to basically leverage both of those in one set of cloud, in one cloud service. So let's choose a new one, and we're going to call this the Azure VM Demo. You'll notice that you get a public DNS IP address for this cloudapp.net. Microsoft owns the cloudapp.net domain, and you choose the DNS name that you would address your cloud service to. You then choose the location of where you want this to run. What's important to note is that if you want to choose a location closely or closest to where you believe most of your users will leverage it to minimize latency. You then choose a storage account. So I'm going to create a storage account. Remember, this storage account is the one that stores the VHD associated with this image. An availability set is the way that Azure basically makes you ensure that you have two versions of the instance in the same availability set to ensure that any issue or patch update that the Azure system or platform does to your base image is guaranteed to only roll across one of the machines in the same availability set. So most customers set up an availability set based on a web front end set, a middle tier, and a SQL tier. So we're just going to create none right now. Now what's important to note is that Azure out of the box only opens up 2 ports. It's locked down by default. There is remote desktop set up so you get access to RDP into this server as an admin, and then PowerShell is also provided to allow you to leverage PowerShell. Now you can remove this, and then notice also that you've set up multiple other ports based on what you need. So there is HTTPS, there's HTTP for port 80, as well as you notice that SQL Server, MS SQL, if I choose MS SQL, 1433 is the default port for MS SQL. So if I was going to have a connection that would allow me to connect to this SQL Server either through a web front end tier or through SQL Server Management Studio or some other application that needed to access SQL Server's database structure, you would add this port. So let's just remove that and start. Notice that also there is a great amount of DevOps feature set added into Azure in particular, although we won't cover it in this webcast. There is support for Chef and Puppet to do DevOps and rolling updates of your VMs using those tools. And you also have the option to install semantic endpoint protection and Trend Micro as part of this offering. When you run this, now you notice it starts provisioning. Now, I'm going to leverage another instance of a cloud service. So let's look at what's happening here. What's happening now, if we refresh the browser, is that this VM and this public IP address is provisioning. What I've done prior to this is I've created another cloud service called IIS DevTest WFE. Let's look at the instances that are in this. Notice that this is a 7, and what this is 7 web front end servers and a SQL Server back end. 7 web front end servers provisioned from a baseline image, and then a SQL Server using the SQL Server image. So let's connect to this server and RDP into the server to look at what it's doing. We go to the virtual machines, we click number 7, and we hit connect. We connect in. Now you see we're RDP'd into the server. Now when I initially created this from the baseline image that we chose earlier, IIS was not installed. So once this machine now comes up with Server Manage, I simply went through the process of creating or installing IIS through Server Management. So I added roles and features. And we'll wait a second here for this to spin up. And then I went through and created notice that I chose IIS and just went through the installation process. So if you notice here, let's go back to the server, to the cloud service. Notice that the web front end in the dashboard here has 7 servers running, and we'll talk a little bit about monitoring and performance later. You'll notice that the service endpoint is this DNS name. If we open that up, which is here, you'll notice that I have web server 6 being hit. But if I open up Mozilla here, you'll notice I'm hitting web server 3. Oh, now I'm hitting 6. I'm trying to demonstrate that load balancing is built into this product because I have set up a web front end load balancing on the HTTP endpoint. So let us go and show you where that's at in the portal. If we go back to the portal and we look at each virtual machine on the Endpoints tab, you'll notice that besides PowerShell and RDP, which was configured automatically, I enabled HTTP, but if you'll notice, it's actually created as a load balance set. So this is a way that you basically create use Azure's automated load balancing to do round-robin load balancing on the web front-end tier. So one question that you may come up with is, now I've got a virtual machine and I have all my full access to install whatever I want. How do I use or capture this as my baseline? And that's very simple to do. If you run sysprep, in the sysprep command folder, and you run sysprep.exe, what you do is you create a out of the box and you generalize it, and then you shut down. And what happens here is that basically what you're doing through this is creating a virtual machine image that can basically be repurposed. So when you go through this and you hit OK, sysprep starts working, and this will take a little while. So usually it takes 5 to 10 minutes depending on how much of your software you've installed on top of the baseline image. So I'm just going to go out of this and show you what ends up happening. After it's sysprep, the image shuts down after it's collected the necessary information. Now what I've done back here is in the cloud service itself, you'll notice the instances for number 5 is shut down. So what I've done is I've run the sysprep command and let the machine shut down. If I go to that virtual machine, you'll notice this, you'll notice the capture command. When you capture this, what you do is, let's call this the Azure IIS Gold baseline. And I say, yes, I have run sysprep, and I hit OK. What it does then is capture this, and now what you would end up with after it's available, when you hit new in the gallery, from the gallery under My Images, after a little while, notice that this baseline image is now available. So this is a way that I captured an image that I provisioned in Azure, and I actually baselined that image. So this is the way you can have a baseline image of a number of images depending on your workload and use it to tear up and tear down and reprovision it. So when you now, instead of choosing a Microsoft image, you choose your images, and you go through the same process of creating the virtual machines just as you did before, and this allows you to basically provision an image that you have created. Let's talk a little bit about hybrid connectivity and networking in general in Azure. The Azure Virtual Networking capability allows you to extend your virtual branch office and data center into the cloud. You can extend your enterprise network through a secure IPsec VPN, and allows you to basically domain join your Azure instances in Azure to your network. So you can actually have hybrid apps where you have certain portions of your app perhaps running in Azure, but the database may be still running in your data center based on compliance requirements. As I mentioned, the network is completely protected through IP address persistence, and you are allowed to do direct internet protocol communication between between virtual machines. So what are the virtual networking scenarios that we typically see? We see hybrid public-private cloud scenarios. Enterprise identity and access control is a typical workload for virtual networking, where you want to use your existing authentication store and Active Directory, and you want to use that in Azure as well, through basically domain joining or adding those Azure instances into your domain. And then you can also do remote monitoring and management of your Azure resources using your on-premise monitoring and application management platforms such as System Center. And then you can also do, as I mentioned earlier, advanced connectivity requirements around IP addressing and direct connectivity. Now, one of the interesting items that has recently been announced, and what are your options around virtual networking? There is site-to-site networking, which is a secure point-to-site connectivity option where you are guaranteed a 80 megabits per second connection to Azure and up to 254 clients per virtual network. Site-to-site VPN connectivity is where you create a virtual network between your VPN device on-premise into Azure through IPsec. Again, you are guaranteed 80 megabits up to 100 megabits throughput. Now you can also create a private site-to-site connectivity through the offering recently announced called ExpressRoute. This is a partnership that Microsoft has with Level 3 and Equinix for large-scale, high network capacity requirements, anywhere from 10 megabits all the way up to 10 gigabits. It's through an exchange provider and network service provider that is certified to connect to Azure. So if you need that, you can do that. From a comparison perspective, as I mentioned, based on your requirements in terms of bandwidth, security management, and workloads, you can see that the capabilities go all the way from point to site, all the way up to ExpressRoute. So if you need mission critical capability greater than 100 megabits connectivity between your on-premise network and the Azure cloud, then ExpressRoute is an option to look at. And then site-to-site and point-to-site is also very viable. We have a lot of customers doing site-to-site, and then to extend their on-premise network, they create an Active Directory controller in Azure that is a backup to their on-premise network to allow them to synchronize their AD credentials, and also as a first step to doing DR in the Azure cloud. So let's go through a demo of creating a site-to-site virtual network. So what you, again, through the Azure portal, you go to the Networks tab and you create a new network. So let's call this the Hybrid VNet network. Again, remember the data center. So you always want to put the network closest to your existing on-premise network to reduce the amount of bandwidth and latency. And we hit our here. Now this is your on-prem DNS server, so I'm just going to call this the on-prem DNS. And for our demo here, I'm going to call this the our on-prem DNS server that would be part of the addressing screen. So this exists in your internal network. Now you create a configure site-to-site. If we were doing ExpressRoute, we would check this box, but we're not going to do that in this demo. We then choose the name of our virtual network. So I'm going to call this the on-prem. And then this is your VPN device. This VPN device is your device that's exposed to the public cloud that's going to connect your on-prem network to the Azure VPN. So this is your internal VPN device. So I'm just going to put in some bogus numbers here. And then you add an address space of where you would like this to go. So what is our addressing space scheme? So we're going to start at the 0.0 and we're going to provision it as a 24 level network based on the number of machines we're going to domain join. And then we add a gateway subnet at 0. This is the gateway connection between your on-premise network and the Azure cloud. And now what's important to note here is that this is how you set up your subnet scheme. So typically what we see customers do is they create a web front end network that's a 10 dot, and then they create an app tier. And then they create a data or back end tier. Let's call it the back end, depending on what their requirements are. And then you hit check. Now this takes a little while to provision, so I'm going to basically go through a demo that I recorded earlier to show you what ends up happening. So once the hybrid VNet is created, you see it here. The next step you do is that you click on the Create Gateway button. That asks you to create the gateway. You say yes. And then what it does is it creates the link. But you have to link your on-premise VPN device, which is supported by products such as Cisco or Juniper. And you download, you choose the vendor and the platform and the operating system. So Cisco, Juniper, a number of other vendors are fully supported. And you download the device, and it actually provides you a configuration file. You open up that file, and then you'll notice here that you click on the there are certain portions of the configuration file that you need to configure certain values for, depending on the IP addressing scheme that you configured on Azure. So in this case, we created, notice, a 10.10 for the gateway and a 1.168.1.0 addressing scheme. And then down here, you create the routing scheme depending on your gateway IP address that was configured in Azure. You enter that IP address here and also in the next one, and you notice it's entered twice. And then you grab a key. So there is a shared key that must be used to ensure that the connection is based on what was the security key created by Azure for this virtual network. You copy that shared key, and then you enter it here. After that, the configuration is done. You then open up your actual VPN device, and you configure that device through your tool. In this scenario, this is a Cisco ASA device. You open up the command line interface. In this scenario, you copy in that script, and then you send it. You refresh. You'll notice over here what was created was an Azure network. You then go into the Azure network, and you'll see the addressing scheme is here. And then after that, it's joined. At this point, you basically have a connection from your virtual network into Azure. Very simple and very quick. So let's talk about the Azure value proposition for DevTest. With your MSDN subscription, as noticed earlier, you get access to tools and services provided for you through Microsoft. That includes automatic and free Azure Compute subscription provided to you on a monthly basis. You get access to Visual Studio Online as well as early releases of software. Obviously, you get technical support and priority support from NSDM forums as part of your subscription. And you also get reduced costs for dev and test environments in Azure above not only the very inexpensive costs that we'll talk about in a little while here. Visual Studio versions have no charge consumption built into them. And you also, as I mentioned through that demo you saw earlier, you get cloud usage rights for Visual Studio, SharePoint, SQL Server, BizTalk, and now Windows 8 and others. You do not need a credit card to set up the subscription. It's pay as you go. If you exceed your subscription allotment for the month and you choose not to allow Azure to go over, you then basically, your instances stop. It does not cancel your subscription. Your instances are basically stopped until funds are then ready for the next month. Now, if you look at the costs here, this is a tremendous savings. So for a sample here, this is a Windows Server standard per hour cost for one specific instance. The MSDN hour cost is reduced from anywhere between 33 and 97% for SQL Enterprise. So that is a tremendous savings based on you having an MSDN subscription. Now, one of the, as I mentioned earlier, you want to look at leveraging both the basic and the standard tiers and what that provides you with, because the savings are even further reduced. This is based on the standard tier, but a lot of our customers, when they're not having a requirement around high availability or SLA requirements, that we tell them to provision basic instances, and you get even further reduced savings. So to give you an idea of those credits, if you have an MSDN professional instance, you save $50. You get $50 per month of Azure consumption. If you have Ultimate, that gets you all the way up to $150 per month. So if you are trying to understand what that means you can run 3 virtual machines for 24 hours a day. You can create a load test consisting of 80 virtual machines for 20 consecutive hours. And you can also spin up 500 websites and a SQL database for that cost. And remember, you're only paying for what you use, so that when you don't need the instances running, you shut the instances down and to reduce your consumption. So let's talk a little bit about SharePoint Server on Azure. So DevTest in SharePoint is a typical difficult workload to provision because of some of the challenges with installing SharePoint. You have to provision infrastructure with your team. If you think about DevTest, not only SharePoint, but in general, the utilization is very low. It's not used at night, and it's not used on weekends typically. So there's low utilization. SharePoint also has a constraint on hardware and software budgets, so that's another challenge. Infrastructure maintenance is complex based on the requirements for implementing SharePoint. And you may have an issue around capacity constraints to support the SharePoint workload. Scale testing SharePoint realistically is difficult on-prem unless you have a very professional or mature application performance testing team in place. If you do SharePoint Dev Test on Windows Azure, as you notice, you can provision a SharePoint instance that is a trial version of SharePoint that allows you to basically provision and run SharePoint in a trial mode for a limited number of time on the SharePoint trial. So you can provision SharePoint, literally a SharePoint farm, as we'll talk about later, using automation, can be provisioned in under an hour. That reduces your infrastructure provisioning cost. Not only that, but also gets you up and running on a SharePoint dev test environment 20 to 30 times faster than having to go through the typical on-prem implementation. You can scale up and scale down as needed through autoscale, and you can ship tested scale scenarios leveraging the Azure cloud for that. And then obviously, if you domain join it, you can also use it as part of your existing authentication store to test the security model around SharePoint. When you look at production implementations of SharePoint, we have customers moving their SharePoint to the Azure cloud. This is what it typically looks like. So we've already talked about a lot of the building blocks here. You have a Windows Server Active Directory with a VPN tunnel, with a domain controller that basically is a backup of your existing domain controller. And then you have a set of application servers in one availability set. You have a number of web front-end servers in another availability set. And then you have a SQL server in another availability set. And you can scale up and down these tiers based on whatever you need to determine your load and whatever else your requirements are. Similar to SQL Server is a very, has great value proposition to run in Azure. The use cases that I highlight here in bold are the ones that frankly are low cost of entry and are being used tremendously by our customers based on the storage architecture built into Azure primarily. So SQL Server 2012 with Cumulative Update 4 as well as SQL Server 2014 supports native backup to Azure of your SQL Server databases into Azure Storage. So keep in mind, as I mentioned earlier, Azure Storage has 3 replicas of your data anytime you store something in that storage subsystem. So you basically get DR built in out of the box if you back up your SQL Server databases to Azure Storage. And as you can also do disaster recovery or via log shipping to basically leverage Azure as your DR data center. And remember, because it's in a data center that you only have on when you need it, the cost for a DR solution in Azure is much, much cheaper than you having to build a second data center with all the infrastructure costs to build the data center, the server provisioning, the installation, and having that data center running in a hot standby when it may not be needed. What are the benefits? As I mentioned, lower cost, faster turnaround times, and less risk. So how does this typically work? Notice here in the business continuity solution, we are doing an asynchronous commit through the VPN tunnel to run backups in Azure. For a cloud backup, it's very simple. You basically have a domain controller through your on-premises network that allows you to basically use Azure Storage as your backup repository. So a lot of customers are using this scenario for their SQL Server DR backup. So let's talk about DevOps and management of your Azure cloud. So many of you are familiar with the DevOps term. We see 4 areas benefiting from DevOps. They are typically application delivery, resource optimization, availability, and pressure to innovate and to be better, faster, and smarter than your competition is always a top priority. IT has been identified as a key player at the CXO level to help mitigate the problem. Business decisions demand higher agility from dev teams. Your businesses require faster deliveries in shorter time and higher quality. Bug fixes must be done as soon as possible. Operations is typically faced with an unprecedented pressure to support ever shorter deployment cycles, but other than the devs, they are still stuck with the old model. So to solve that, the solution is your operations teams must be involved as early as possible in the life cycle when you deploy into the cloud. In that sense, an app is not like a child that hopefully once old enough leaves the house and cares for itself. An app is a lifetime commitment for devs as well as the ops team, and the DevOps unit is all about helping to accelerate that delivery. From a resources optimization perspective, plenty of work is still done by most companies in a one-off mode. Only few critical tasks are automated to the extent required to support agility demanded by the business. Lengthy hardware purchasing processes due to budget and data center resource restrictions lead to more delays in getting deployments of new products or features. This situation forces development teams and frankly your businesses to reach for other solutions that get their specific business use case at least to the point where they can test it using either an existing off-premise or they provision and have basically what we consider cloud spread without the IT team actually understanding what cloud assets are being deployed across your enterprise. In a DevOps model, operations developers would work hand in hand with other teams like security and networking. Resources would be allocated through a regimented but still sort of open self-service provisioning model where the data center team would still have control of what business units or businesses get instances provisioned in the Azure cloud. In terms of availability, that obviously, as we've talked, is an important aspect that the cloud provides. Because of the redundancy built into the cloud at all tiers, troubleshooting becomes an issue to teams who don't properly instrument and automate their solutions in the cloud. Predictable deployment in dev, test, and production supported by automation and proper tooling is essential, including self-service infrastructure and automation through PowerShell and tools similar to that. Really, in terms of DevOps all up, as you understand DevOps, DevOps is around optimization, pay-as-you-go, automation, and ensuring consistent coding practices and deployment. And as you see in the diagram here, you're trying to do a repeatable, cyclical continuous integration, quality gate approval, and provisioning process to production through DevOps. DevOps still focuses on leveraging the ITIL v3 framework in terms of better communication, building software and establishing baseline releases, implementing continuous delivery, and automate and amplify feedback loops. So what is the linchpin from our perspective to leverage DevOps and automation in Azure? The answer is System Center. System Center 2012 Cloud and Data Center Management Solutions empower you with a common management toolset for your private and public cloud applications and services. System Center helps you organization consume and deliver IT as a service by enabling productive infrastructure, predictable applications, and cloud on your terms. System Center helps you deliver flexible and cost-effective infrastructure with what you already know and own. System Center helps you integrate heterogeneous data center environments, including multi-hypervisor environments. System Center does not only support Hyper-V. There is support for VMware as well as Citrix. From a process automation perspective, System Center and the orchestration offering, you can integrate and extend your existing tooling to build flexible workflows or runbooks that span multiple organizational silos and systems, which are then orchestrated through automation. System Center Service Manager offers industry standard service management capabilities based on ITIL and MOF, which automates core organizational process workflows like incident management, problem management, change management, and release management. Self-service infrastructure. With the provisioning capability of Virtual Machine Manager, you can pool and abstract your data center resources into a private cloud infrastructure fabric, which is then maintained reliably by Virtual Machine Manager and Operations Manager. You can allocate and delegate this pool fabric to your business unit, IT organizations in a flexible yet controlled manner using Virtual Machine Manager and the all-familiar identity and access service provided by Active Directory. Application owners can consume capacity and even request additional capacity in a self-service mode using the service catalog offered by Services Manager, which might kick off an automated process workflow with Orchestrator to instruct Virtual Machine Manager to verify and provision the requested capacity as appropriate. Keep in mind that allows you then through automation to provision those virtual machines in Azure, still using System Center. Server application virtualization, a feature of Virtual Machine Manager, optimizes your existing applications for private cloud deployments with sequence state separation between the application and underlying infrastructure, acting as a bridge to the cloud. System Center 2012 offers a service-centric approach to help you maximize business impact while also unlocking application mobility in a controlled manner between your cloud environments when it's time. What this allows you to do is to construct and manage clouds across multiple customer data centers, multiple infrastructures, and service providers. System Center 2012 has an Azure management pack built into it that allows you to see your on-premise virtual machine infrastructure as well as your Azure infrastructure seamlessly through one pane of glass. That allows you to use System Center's built-in alerting and monitoring tooling to allow you to basically monitor your Azure assets using the same framework. Linchpin for automation in the cloud on the Azure platform is PowerShell. You can automate pretty much and provision and alter virtual machines not only in the IaaS offering but also in the PaaS solution through PowerShell. You can create virtual machines, you can domain join to Active Directory, you can copy your own images, you can provision images, you can capture VMs, you can configure your network, and you can upload and download VHDs all through PowerShell. The important thing to understand is that controlling cloud consumption costs can be done in three ways. You can manually shut down VMs using Visual Studio, the Azure portal. From a semi-automated perspective, you can leverage Azure PowerShell to start and stop VMs as needed. But from an automation perspective, and what we do for our customers is we still leverage Azure PowerShell or REST, but we also implement Azure Autoscale features to start and stop on a schedule, or based on performance metrics, or as I mentioned, System Center and Runbooks do that for you. Autoscale and monitoring features built in. You can autoscale virtual machines up and down based on multiple schedules, based on times of day, based on specific events. You can scale by CPU percentage. From a queuing perspective for storage, you can based on queuing metrics. Your auto-scaling configuration allows you to shut down and provision images in a staggered manner, meaning that if you only want to implement or turn on or spin down one instance at a time, the think time or wait time algorithm is built in so that you don't provision multiple instances automatically. It staggers up, it staggers down. You can also monitor cloud workloads across cloud services, VMs, websites, mobile services, as well as your SQL and database tier. Your storage tier. There is an alerting engine built into Azure, so you can not only do alerting based on performance metrics such as CPU or queuing, but you can also get alerting based on your consumption as well. You can have an email sent to your Azure subscription administrator based on your CPU percentage being greater, in this example, for 5 minutes, and get an email sent. But in the instance, you can also set up alerting engines on your consumption costs when it exceeds a certain threshold. And here you see the email that I received for our MSDN subscription when it exceeded $5. So let's look at each one of these and quickly cover PowerShell automation. Let's go look at the Azure portal in terms of monitoring. So if you notice here on our web front end cloud service, under our instances, we now have only 1, 2, 3, 4, 5, 6, including the SQL Server running. If we go to the Monitor tab, you now notice that we can see performance metrics built into the portal. We can add metrics to the portal if we wanted to look at CPU percentage and add that onto the chart. We now have it down here. The other option you can do is you can add individual monitor not only at the cloud service but at each virtual machine level. So maybe you want to look and add one into here, and you want to look at the monitoring capabilities for that specific virtual machine itself because you're interested in that. Let's look at the auto scale feature. So on a cloud service, if we go back, you'll notice scale. So auto scaling is set up based on the availability set. So you notice that I have two availability sets. All the web front end servers are set or configured to run in the web front end availability set. So I can actually set up a schedule that says I want a different scale setting for day and night, and I want different scale set for day and weekends, and I want that to start at 8 and 8 p.m. and I hit OK. And now I set up, I want the alerting or the auto scale settings for weekday to be a maximum of 1, and I want 3 running, and my target CPU as to when that functioning should be not active is between 60 and 80%. And I want to scale up by 1 instance every 20 minutes to allow the system to react, and I want to scale down. Notice I also have that option for DevTest SQL if I want it. So if I save that, you'll notice that autoscale is now configured. Now in a little while here, you should have basically auto scaling kick in, and if we look at our instances here, you should start seeing instances of the web front end start shutting down based on CPU percentage. Let's look at the alerting feature built in. We go down to our management services and we look at alerts. We can add a rule on our alerts. Let's call this the CPU alert. And we want to choose the cloud service and we want that basically to be, we want to choose a virtual machine, and we want to choose that virtual machine, and we want to say that the CPU is our metric for if it's greater than 50% over last 5 minutes, send an email to the administrator, or you can actually specify another email address and you alert the rule. I'm just going to do this and check it. That CPU alert is now configured, and an email will go to the administrator whenever that CPU percentage is over that amount for 5 minutes. So let's go back and look at the cloud service. And see if the instances are shutting down. You now see that the DevTest 3 and 6 is shutting down based on our auto scale rule. So that is how simple it is to auto scale up and down. And notice you can also automate this through PowerShell. So how do we automate this through PowerShell? There is a set of PowerShell commandlets in Azure called the Windows Azure PowerShell commands that you run through PowerShell, the tool. There is a Windows PowerShell ISE built in for those of you familiar with PowerShell. There's also a third-party tool that I like to use for debugging purposes called PowerGUI, free of charge. If you run get help Azure, you'll notice that these are all the commands that you can run in Azure. Very rich. Really anything around provisioning, automating, creating, shutting down, removing, and changing Azure settings for any VM that's in Azure can be done. If you need help with getting examples of how to use the get Azure command, simply through becoming familiar with the tool, it will give you an idea of how to run the command itself. So let me clear this out here. So you can see the output just from that execution. So here you notice the command is get service name. That gets your service name. Here's an extension of it if you need to do additional work where you get into the innards of PowerShell to do much more automation. So that's one option. Now here is a PowerShell script that we typically use for our customers, and you'll notice that this was our target service here. Remember, that is the service that's in the cloud service name, and I'm basically going to initiate a shutdown. I'm going to hit stop, and I'm going to basically shut down all the VMs that are in this set of cloud services. So this is the way you control consumption on a nightly basis. You can use auto scaling to do this, but a lot of our customers use PowerShell automation to provision and automate not only spinning up machines, provisioning those machines correctly based on baseline image, but also to start and stop based on those instances running. What you do then is simply run through PowerShell. You loop through each of the virtual machines, and to stop the VM, you issue the stop Azure VM command with the instance name. So let's debug this a little bit and run this. So one of the interesting things I like about this is that PowerGUI gives you a rich sort of debugging experience around the virtual machine. So if you notice here, you have 8 virtual machines. We take a breakpoint here. You'll notice that the virtual machine instance name, once it runs, is shutting down IIS DevTest 1. So it's in this shutdown command right now. So let's go back while this is running, because it's going to loop through this for loop each time, waiting on the shutdown command to execute. So when we come back up here, it will break. So let's look back at the, you notice this is stopped and allocated now. In a second here, you'll notice it's stopping IIS Dev 2. If we now go back here and refresh the portal, you should see the virtual machine for the instances stopped. So this is a way you can see through PowerShell automation that all the instances are being stopped. So in addition to stopping and starting VMs, as you just saw, let's actually provision a SQL Server itself. So in this scenario here, I'm creating a SQL Server image, giving it the username and password to this cloud service itself. The VH image name will be DevVM, and I'm going to actually create that through the new Azure VM config command, allowing you to create data disks and log disks. In this scenario here, I'm creating two and attaching two data disks to this baseline VM of 100 gigabytes for data, 50 gigabytes for logs. I'm also opening up port 1433 for Microsoft SQL. If you recall, when we were looking at that port open earlier, and we're provisioning it. So let's run that. You'll see the virtual machine provisioning has started. Let's go back to the portal and see what's happening. So in the cloud services tier, you'll see that a cloud service has started, and in the deploying stage right now the instance is not created yet, but if we wait a couple of minutes, and we'll do that after we wrap up this presentation so you can see it, the actual image itself will be created. And I think the virtual machine is actually now available through the instance tab. One instance is starting. Notice this SQL Dev VM is now starting. The provisioning process typically takes somewhere between 5 and 10 minutes. So PowerShell is the key to automation in Azure, along with System Center as your foundation for monitoring and managing your cloud assets. Let's talk and wrap up around Azure workloads and best practices. What are we seeing out in our customers? The breadth of Azure really is allowing us to see customers doing not only application development and migration, but big compute and big data is a very large workload moving to the cloud, simply based on the unlimited amount of compute power that's available to you to process large amounts of data for the time you need, and then shut down those instances once the data has been stored and properly analyzed into a format you can then consume through whatever provider you need. Business analytics is also a large workload. I cannot emphasize enough the connected devices story about how you can use Azure Mobile Services to write apps that target not only Windows devices but iOS and Android devices. Obviously, we've talked about scalability and massive scale for if you have a website front end for your e-commerce transactions. Azure VMs disk configuration, the best practices, a couple of notes here for you. You are guaranteed 500 IOPS per disk. You are up to 20,000 IOPS per storage account. And you have not a 200 terabyte capacity, but a 500 terabyte capacity as of this recording. And you have to plan for capacity and set up a proper disk configuration and architecture based on how your virtualization requirements are. The disk caching built into Azure is set for you automatically. By default, the disk caching is set to read-write. And you can change that either through the Azure portal or through the PowerShell command set Azure OS disk. You can modify the disk caching setting based on requirements, perhaps in terms of SQL, to require cache settings based on your IOPS or your throughput or what the SQL disk is doing. You can modify that through the set Azure data disk command as well as the portal. In addition, you can reduce your number of hops by using direct IP between VMs instead of the load balancer. And as I mentioned earlier in preview, internal load balancing is now allowed. That allows you another option to basically change the network configuration of your infrastructure. I wanted to make a note of what one workload that we strongly emphasize you look at, and that is the data disaster recovery and leveraging cloud storage to as your mechanism for DR. There is a StoreSimple device. Microsoft bought a company named StoreSimple. This is a fully redundant, highly efficient SCSI and SATA disk that is installed in your data center that basically makes your data center have Azure as a iSCSI cloud volume. This allows you to basically take your backups, which you are either taking off-site or to a backup drive, and actually back those up natively to the cloud as part of your network. The actual device looks to you through Network Explorer as a data disk that you can use as you deem fit. It's very highly performant, ensures that the most recently accessed data is actually stored locally on the device, and has a very rich API to determine what data needs to be stored locally on the device. One item to note is that there's military-grade encryption built into the device that basically encrypts the data at rest and in transit to Azure. So if or when that data was ever opened up in Azure, either through a third-party utility or some tool that for some reason had access to that storage account, the data itself would be unreadable because you manage the encryption keys and the storage account. What this allows you is fast on-ramp to the cloud, and we've seen customers who implement this device get TCO storage costs reduced by 60 to 80%. Depending on an EA agreement you have in terms of Azure with your Microsoft rep, you can get this device at no cost, depending on your EA commit. So that is it. I want to thank you for spending the time with me on an overview of Azure and how you can leverage that for DevTest. As I mentioned, you can contact me via my email or follow me on Twitter, and we look forward to talking to you about how we can help you with your cloud migration to the Azure platform. Thank you.